So we will speak about the role of mathematics and process theories in consciousness science. It's going to be also kind of general. So first, to start, I would like to ask you how many philosophers are in the room? If you can, okay. How many cognitive scientists or neuroscientists are in the room? Okay, interesting. How many mathematicians are in the room? Okay, interesting as well. Beautiful. Computer scientists or physicists? Beautiful. We have a very diverse audience, actually. Well, I ask that just because when I tend to speak about these things to my colleagues from cognitive science and neuroscience and sometimes philosophy, they tend to react like that. Oh, no, too much mathematics. But then when I speak with my colleagues from mathematics, they actually have this other reaction and they say like, well, what we are doing is poetry. So let's try to see if we can find a balance in between these two things. Basically the presentation is gonna, if you need to leave this room with at least one thing, maybe I will think three things, but if you leave with the message of this presentation, is basically this one here. So we can apply category theory directly to the experiential structure. We will kind of define these things hopefully during the presentation. Applications may bring what we call in philosophy mathematical constraint-based type of explanations. And finally, I would like to argue that these explanations require a phenomenal act of reconfiguration, transcending perception, but also ground in its infrastructure. So basically saying that mathematics, it's a phenomenal structure by its own right. And that's why it allows us to also study phenomenology in the way that we are suggesting to do it. So let's see. I'm not claiming that I will convince you in 20 minutes, but at least we plant the seed and then we can discuss later and hopefully during the day. So very quickly, I'm not expecting that you read this, of course. Please don't do it. I just want to point out this. The presentation is going to have two main sections, basically. So the first one, we will focus on this idea. Differently than any other scientific area, consciousness science presupposes the same kind of experiential primacy that mathematics presuppose. And then the second part of the talk, probably quick, is going to be a very naive application of process theories to study empirical causal structures of conscious processes per se. This is a work on process, so it's not something published. But all the things that we were speaking before that there are published, I'm not going to speak about this, but you can look through the papers, and some of them it's gonna appear in Harness talk, for example, tomorrow, etc. So that's more or less the structure of the talk, and I think that it's going to be around 20 minutes. So let's start from the basics. So mathematics. Sometimes we forget what is mathematics, and we think that mathematics is just numeric computations or things like that. But actually, mathematics is the science and study of quality, structure, space, and change. Mathematics seeks out patterns, formulate new conjectures, and establish truth by rigorous deduction from choosing axioms and definitions. So why I like this definition of mathematics, because it kind of gives us a broad perspective. Mathematics is not just numbers, it's much more. And category theory is one of these things. It's conceptual mathematics, let's say, that allow us to conceptualize mathematical structures and their relationships. It's like how we think about mathematics. Of course, then we can compute things, and that's the amazing work that we saw previously. So, but it's based on this idea of concepts as well. And that's why I really like this. I put it in almost all my presentations. If mathematics is the science of analogy, the study of patterns, then category theory is the study of patterns of mathematical thought. That gives us a perspective, and especially here that we're speaking about consciousness and phenomenal experience as well, etc. So we can apply, of course, category theory. We saw that in Johannes' presentation. We can apply it to models, and mainly models that tend to be about the brain. And in this case, for example, is what we saw. It's the work from Sean and Johannes and the structure of IIT, for example, what we saw previously about the structure of predictive processing, And it can be applied to many other models as well. We can apply it to the mathematical machinery, but also to the neural machinery if you want. And another option is to apply it to experience directly, to study the structure of experience in categorical way. So that's something that it's another alternative. And I would say, like in between, for example, is the work mainly of now, that it's trying to link these two things. Let's say. So I would like to say that it's these kind of possibilities form part of a hopefully increasing family as well of new applications of category theory to the study of experience. A very nice family, I guess. So something that we need to take into consideration when we apply category theory to models of consciousness or to models of how the brain works, for example, and when we do it to experience itself, it's a very slight distinction on what is the mathematical explanation or the way how we use mathematics when we target these two phenomena. And here it's like we say applied mathematics, let's say. So the use of mathematics to ground explanation. In this case, we tend to focus or emphasize causal powers and natural laws. So mathematics is like an instrument or accessory to the explanation. But then there are also distinctive mathematics, let's say, which is mathematical facts are the explanation itself. And in this case, the mathematical fact emphasizes constraints and its inevitability, like a strong necessity, let's say, in philosophy, instead of causal relationships. There is, of course, a question. This is a very, very, very new debate. Actually, it's papers from less than 10 years, maybe 5 years or something. That in philosophy of mathematics, there is this type of distinction. And to give you a very quick example, I think that all of you got more or less the idea here. If you want to answer the question, how many equilibrium points it has a double pendulum, you can opt for different options, but mainly you will try to find the different forces, try to generate an equation of these different forces where the final result should be zero. So then you know that solving the equations you will get four points of equilibrium. These ones here. What is doing the explanation here in this side, let's say, it's the Newton's law. So that's what it's explaining the situation here. But then another question, perhaps a little bit more abstract, it's what made any double pendulum have at least four equilibrium points. And then you can ask, well, in this general square pendulum, why we find the same thing, although the physical situation is different, although the way how you combine the forces is going to be different as well, and the number is perhaps different as well. But at least you know that it's going to be 4. And then you do the abstraction. That's what mathematicians do, of course. And we abstract, and we realize the configuration of the angles here form a torus. And in order to make the potential energy 0, it should satisfy the equation of number of maximal, minimal, and saddle points here. And when you solve that, you know that it's at least 4 points. But it could be 6 in a few cases. So that makes you a kind of perspective of how these things can work. Here the explanation is physical. Here it's not that you don't have physics, of course, but the explanation is a mathematical fact, in this case a topological fact. There are other type of explanations where the connection with physical systems or with the physical forces, etc., causal forces, etc., it's not, or it's less clear, let's say. And I will give you basically 2 here. I will need help with the pronunciation of this one, so maybe Johannes, you can help me. The 7 bridge of Königsberg.
You have to be a bit relaxed.
Königsberg. Great. So hopefully most of you know this example here. So basically the example is super simple, and the question was, can we cross the 7 bridge of, now you know the city, without crossing twice the bridge, so crossing just once basically. And people tried, you know, like people went there, they were trying to do it seriously. No one succeeded. So why? Why they couldn't succeed? It was someone trying to shoot them, causal explanation. It was someone trying to bomb the bridge, causal explanation. No, it was the configuration of the bridge that was not allowing you to cross the bridge only once if you wanted to complete all the path. And that was Euler. Well, I don't know if that's the right pronunciation in English, but at least it's like that in Spanish, Euler. What he did, it was to abstract the situation, to reconfigure, let's say, a physical situation into this more simple way to define the problem, and realize that actually the only way to cross everything and solve the problem, it was when the land masses, or like represented by the vertex, were having an even number of bridges instead of an odd number of bridges. And unfortunately here you have this one is odd, and this one is odd as well, so it's basically impossible to cross all of them only once and generate one path. This is a mathematical explanation which is abstracted from the configuration, topological, let's say, configuration of the situation. And then there is another one, maybe more people here is familiar with that. It's contextuality, for example. So entanglement, quantum entanglement cannot be explained by causal forces connecting one thing with the other one. So basically you can, the physical and mathematical situation, you can extract it or abstract it in such a way that the probability distributions cannot follow or cannot generate a global consistency across the local ones. So of course we can discuss more the details. I guess that most of you know or are familiar with this, but that's the main idea. Okay. So what is common about all these explanations, type of explanations? There are many more like that, of course. It's that all of them require a kind of restructuration, an act of restructuration or reconfiguration. The new structure doesn't exist or doesn't pre-exist the act. The act is significantly creative. It grounds in perception but also transcends perception. And in this line, mathematical insight are phenomenal structures by their own right. So, okay, it's a lot of things here, and you don't need to believe that. You can go to this amazing paper trying to connect phenomenological philosophy with mathematics, based on Merleau-Ponty final works, basically. It's super interesting, but basically, I mean, the idea is that you kind of have a perceptual situation, let's say. You kind of have a symbolic abstraction of that, and then you have several steps of new symbols and producing new ways to represent these things, let's say. And these ways, for example, end up on new configurations of things that we had before, such that you get a mathematical, super beautiful formula that seems to contain a truth that we didn't see before. And it's kind of funny because for us, these things, this is Gauss' equation, these things looks like super simple and super basic and obvious. But actually it took us more than 2,000 years, maybe more, to get to this one. So it's not so simple. There is an act, a creativity act, let's say, from the mathematician as well. And that's why perhaps poetry is not so bad analogy with what we actually do in mathematics. There is something artistic as well. And so, speaking about poetry, maybe that's the moment. I'm not kidding. No, well, it's not poetry, but it's a good moment to read. So something all these explanations have in common is the restructuration or reconfiguration of the original setup in such a way that mathematical facts, mainly topological, seems to explain the physical configuration by making explicit the constraints involved in the particular situation. This corresponds to a process of abstraction that requires a creative act from which the new structure arises. So then the mathematical insight is therefore linked to the production of a new phenomenal structure. A mathematical truth is a structural truth. These constraints can be mapped. You know, like I'm not very good for poetry. Constraints can be mapped both to the structure of the world as well as our cognitive and experiential structure. One example is how cats, that's why the picture here, can't recognize themselves in mirrors, and cats, categories, cannot arise without us studying them. However, what would be the limits of our own experiential structure? This invites us to question our deeper conception of reality. Mathematics itself invites us to use mathematics as a form to explore phenomenal and experiential structure in such a way that it's not reduced to the physical. But what would be that a mathematical framework where structural relationships can be made explicit? Sorry, it was a very long paragraph, but that's why I read it, because otherwise I wouldn't memorize it. So that's more or less the picture here. That's the hope that you know why the cat cannot recognize it himself, because his cognition, let's say, it's based on a smell. So because the mirror is not smelling like him, he thinks that it's another cat. You know? So it's a very simple explanation, but it's a structural explanation as well. You know? So what is missing for us? That's the question of reality. And what is the structure that can allow us to get something from within, from inside, let's say. And that's the second part of the talk. Hopefully quick. I don't know how much time do I have? 10 minutes or something?
So I think more. So we've got 14 minutes including questions.
14 minutes including,
Yeah.
and now it was like 15 minutes or something like that. Okay, well, I have time. That's good. Well, we can discuss more. So I think that I'm kind of inclined, like Johannes as well. Like everything that I do, I need to have some kind of philosophical background behind it. I want to get that support, let's say. Although I'm not a philosopher, but still. So what would be this framework where we can try to get these structural properties and manipulate them in such a way that we get some truth from that? And my take on this is process ontologies. So if you know that, it's an amazing work from Whitehead in almost 1 century ago, but it's something that is getting more and more common these days. Because it's very interesting, like it basically says that spatiotemporal and topological structures of all kinds have to be established in the first place. And conscious experience is found in the process that gives rise to such a structure. So in such way there is a processual primacy. Everything is kind of a process, but there are mental processes, physical processes, they can transform each other, and they are like the same type of family of things. Basically, a process ontology corresponds to a model of the structure of the world as an ordered wholeness. That's very philosophical. The universe is constituted by processes, not things, not information, no functions, processes. A process is a set of transformations characterized by the structural relationships, parameters, and constraints. Processors define probabilities, which in turn underlie physical objects, rather than the other way around. So it's kind of rereading, perhaps, of process theories as well. And processes are drop of experience that ground the notion of information processing. So why I need that justification? Because the next step would be to say, well, let's use process theories to study actually the structure of experience, the structure of conscious experience. And what would be the justification? Well, these processes is what we observe in the world, but also they mirror our cognitive structures as well. So they are matching by default. That's more or less the idea here. And then you get let's say like definition of compositionality in this sense. It would be the whole is constituted by the relations of the parts, and the parts are constituted by the relationships they bear on to one another in the whole. Basically, this means to have two properties: co-determination and not trivial decomposition. So co-determination, the wholes and the parts mutually define each other, and that's what we see basically in conscious experience. I want to define conscious experience, but I need conscious experience to define it. So there is a circularity there, and that's the co-determination. And not trivial decomposition, so the decomposition of the whole into parts is not trivial. Basically, wherever I decide to decompose has something that is related, still related into the whole. How we operationalize that in conscious experience is basically saying, okay, we will define some processes that are conscious processes, and depending how they compose, then you will get new conscious processes. But you don't start from physical things or neurons or something that would be more reductive, let's say. So you start from consciousness to get consciousness, but there is nothing in between. And here I have some examples, but I think that you get the main idea. Basically, entanglement, it's like the whole grill. It's like the most common example about compositionality and this in this type of relationship. And I'm trying to argue that you find a type of compositionality as well when you study consciousness. But you also can find a type of compositionality in autonomous systems and life, and a type of compositionality in language. That's what we saw early on with Bob's talk. So, what would be a process theory in this sense? We know already. We saw Bob's talk. We also saw Sean talks. So I think that basic you already kind of grasp it. So you know category theory. So in this sense, it's a conceptual mathematics. Process theory in this sense is going to be, well, at least symmetrical monomial categories, which comes with this very beautiful graphical language as well. And compositionality can be operationalized as a set of generators that they compose in such a way that we study the system. And then a scientific question is how experiential processes then compose. We don't need neurons here. We don't need brains or physical gates, something. The question is simple. How experiential processes compose? Can we define these experiential processes? And that's the magic here, like how we do that. So you know already, like the process theory is a collection of systems, a collection of processes, and a way of composing them. So if you, or what I'm trying to suggest here is like, if we want to use these things or to study conscious experience or experience in general, we could define like what would be these systems, these processes, and how they interact. So I will give you a very naive, this is like super naive example, and I just want to do it because it was one of the first things that we discussed with Bob when I arrived in his lab, and to be honest, it's something that is still there in my mind, and I think it's something that I just started to develop again. But it's a very simple idea. The most simple. And it's that consciousness is a process, and it has inputs and outputs, but we don't have any idea of what are these inputs and outputs. So it could be something very complex, where memory it's an input, with identity it's an output that we can measure like in a state, and there are perceptions, intentions, signals here and there, etc. We don't know different nature, etc. So consciousness, here would be like the assumptions. Conscious experience is a process with several inputs and outputs of different nature. By compositionality, we can assume a minimal set of conscious processes that generate other conscious processes. by call determination and not trivial decomposition. And we could rename that, for example, this is consciousness with all its complexity, and we say like, okay, we can decompose that in other two processes that here we will call just awareness and reflection, although awareness could be pre-reflection depending on the authors, etc. I decided to use this just because there are simple operationalizations. Other choice of generators is perfectly fine, and that's the magic of this. Take your best axiomatization, how you define the processes that will form this bigger, let's say, system for different type of conscious experience, etc. And then if you can prove things from that, that's fine. That's it.
2 minutes? Still a question.
2 minutes. Okay, perfect. Yeah, it's more than enough. So then the question is basically how these processes, let's assume that we only have these two, and then the question is how these two things compose. And we can go to phenomenology. So for example, phenomenologically, awareness seems to precede any type of reflection. That's we need to be aware of something to reflect on that. But also if we go to empirical cases and we do experiments, for example, with error detection, we know that in some situations the systems looks to be in parallel or independent. So it's that we have a just sequential composition here or parallel composition. So, well, we don't have any of the two actually. It's a more complex relationship. And the first ansatz, let's say, how the Germans call it, we could define like this is the way how these two things compose. And if you manipulate a little bit more this kind of impose a causal structure. This one is first, this one is second, but also you can discard what is happening here and get what is happening here as well, and the other way around. So they can behave like independent processes in certain situations. And if you move a little bit more that, you can also redefine a new notation of this situation here, this composition of these two processes, in such a way that offer you a new perspective. And the new perspective is that whatever you define originally and you are playing around, that you say that it's conscious experience, let's say, it would be a process of processes, or a process that can transform, for example, processes that are the inputs of this, and not just systems, let's say. So the final notation, this one here, suggests a higher order process that transforms processes from B to D into processes from A to E. So what can we do with these things? Of course, I don't have enough time, and of course, it's a work in progress. But actually, we could go now to psychophysics and things like that, and try to re-explain things that we haven't explained yet, or explain it in a new way that it's not mechanistic. So basically, this structure that eventually corresponds to a causal structure, first restrict what kind of processes can be the input of that. So this one can be, this one cannot, and this one can be only if there are certain conditions between B and D that allow, for example, the transposition of this value. So these things impose what we can perceive or not. And then there is a phenomenon which is called the fifth phenomenon. I wanted to show the phenomenon like on the screen, etc. But we don't have time for that. Basically, it happens that you show two different stimuli like that, and in our conscious perception, we see that these things are moving such that you change the color in between. But actually, it's not happening in reality. It's happening in your perception. So the question here is like the mechanistic explanation would be, well, it's something happening outside that is generating something inside in my conscious experience. But if we take like this more mathematical perspective, it's actually the other way around. We perceive this because we have this causal experience, this causal structure that only allowed us to perceive this. It's a constrained type of explanation. It's something that it's a work in progress. I'm not expecting that that it's 100% clear, but that's the main idea. So finally, why category theory? Of course, we have rigor, precision, it can constrain theories. Eventually, I think that we can predict or extrapolate predictions that at least the take on for this presentation is that we can eventually naturalize phenomenology, phenomenal experience, not without issues. That's something that we will see in Robert Pretner's presentation later. Some of these things we will see as well with Andrea's presentation tomorrow. And but that's all. And thank you very much.
Questions. So, any questions? Yeah, you already had to, so I'm going to start with someone else. Yeah.
Okay. I want to push back a bit, maybe on process ontology and process theories, because I'm puzzled about if process theories are actually apt to model process ontologies. Because in process ontologies, if I'm not mistaken, everything is a process. But in process theories, we have some objects, physical systems, whatever. And process ontology seems to deny the existence of substances and this sort of thing. So wouldn't be maybe a better way to model these process ontology, maybe something like a functor category, where the objects are some kind of transformations, and then natural and the morphisms are natural transformations, and so the natural transformations tell us the structure, the web of relations of these processes.
Yes, I think that it's very. I mean, it's a possibility. I'm not claiming like 100% that process theory is modeling exactly what process ontology is suggesting, but I think that it's a very nice analogy. I mean, you get it from the name. The name is already like a very beautiful metaphor, and I would say like maybe there is something that we need to learn. Like that's why I mentioned during the presentation. Maybe these process theories are so nice and beautiful and makes too much sense to us and makes sense of the physical as well, because actually they corresponds to our cognitive structures. And that's something like it's kind of an hypothesis as well in Bob's work. For example, when you try to let's show these things pictures to children and they will get it much easier than if you do mathematics to usual mathematics. If that's correct, that would mean that it's something inside us that makes all these things simple. So we think that there is a connection, but it's true. It could be that it's not enough. It could be that there are other options in category theory as well, but maybe model better this process ontology.
So Bob, yeah?
Yeah, personally I would say the idea of process theory doesn't go back to Whitehead, but to Heraclitus. Because that's where a bifurcation in science took place, whether we're going to focus on the state and then take dynamics as some secondary construction, or you start basically from the structure of change. And so there's two views of process theory, like the way we build them bottom up. Indeed, we've got systems and processes between them, but you could also think of them the other way around. You've got processes, and then you try to instantiate at some point, where are we now? And that's sort of the theory of decomposition. But yeah, but one thing that Whitehead I think missed out on was the importance of composing systems. And that's where the process theory really doing all their work, that you got the two dimensions of composition together. That's really what it's about. Same, the analogy is Whitehead is like category theory, while process theories are like manual categories.
So final question? Oh, so yeah. Either one. Maybe
you can go first and I can go.
Yeah. Did you find anything in Whitehead about process ontologies of consciousness or cognitive science?
You mean? I mean, I'm not an expert on Whitehead. Maybe I should say that from the beginning. I think that basically everything that he's trying to do is try to put the primacy of experience the same. I mean, at least at the same level that the primacy of the physical as well, but actually in the opposite side, such that the experiential is more primary. So when I mentioned that it's the experience who define probabilities, and it's not that probabilities come from, let's say, from physics itself. That's a claim of the primacy of experience. I think that this philosophy is connected with what we are trying to do in phenomenology, it's yeah, like by default, let's say.
Last question here, sorry.
I just wanted to respond.
So I
Just one, yeah. Well,
you go first.
Yeah.
I can go first. Okay. So I think it was the same question. So you think, for example, some people think that Riemann geometry is the best mathematical structure to represent space-time because there's certain isomorphism or structural similarity. So in your case, you are saying maybe that category theory or process theory is the best structure to represent our phenomenology.
It's one very simple way to.
Simple.
Yeah. I think it's the starting point, and that's why it's connected. I think that it's connected with the rest.
Exactly.
I think it's a very nice starting point because it's simple, and you have like the structures there you can play, etc. But maybe higher categories would be like the next step as well. So it's I think that in all the mathematical structure there is some phenomenality.
Okay. Exactly.
And it allows, and that's the main idea of the talk is like any mathematical structure can say something if we put attention about our phenomenology as well. So that's the invitation, let's say, and that's the provocation as well.
Okay, Carl.
Yeah,
Comment.
in a category, the object is just places of like connection. So there's no reason you couldn't have a process theory of processes. It doesn't have to be like processes and non-process stuff. The language is like it's just like a language.
But you can abstract the objects. That's the thing. It's like
just where you plug stuff together.
exactly. But for example, like Johannes mentioned, the object can be quali space. For example, the object can be something that we relate to experience.
Okay, let's give a big round of applause for